Hello, good afternoon everyone. Welcome back to Chemistry is Easy for You. Our topic today is continuing for the IIT JEE aspirants, and today we are taking one of the portion from the General Organic Chemistry part, which is the inductive effect. Inductive effect is one of the electronic effects. So before we go into the topic, let me tell you, many of you asked me to explain in Hindi as well. So the thing is, we are in South India and my Hindi is not that well, but I will try to take the class in Hindi as well from the next video onwards. So please bear with me for this one more video, and in the next one onwards I will be explaining in Hindi as well. So let us begin with the topic today, inductive effect. So we all know that in a covalent bond, there will be, if it is happening between two different types of atoms, their electronegativity may not be the same. That is, in between two different atoms, one can be more electronegative and one can be less electronegative. So this difference in the electronegativity is the basis for inductive effect. So let us suppose here we are having an CX, a bond CX, that is carbon with another atom X. We are thinking that if X is more electronegative than C, then what will happen? If X is more electronegative than C, then the electrons in this bond will be pulled towards X. That is, it will be attracting more, it will be pulling more electrons towards itself and gains a partial negative charge. That is, the full electrons will not go to X, but it will be to the side of X, and therefore it will be getting a partial negative charge, and therefore the carbon will get a partial positive charge if X is more electronegative than carbon. And this effect is known as the minus I effect. This I stands for the inductive effect. So minus I effect means minus I effect takes place when a more electronegative atom is attached to carbon, and this more electronegative atom pulls the electron pairs towards itself. Now let us consider the case 2. In case 2 here, another atom Y is considered. Here Y is less electronegative than carbon. If Y is less electronegative than carbon, then what will happen? This electron pair will be pushed towards carbon. That is, now electron will be lying more towards the side of carbon, and carbon will gain a partial negative charge and Y will get a partial positive charge. This delta means that it is not completely minus, but just having more number of electrons compared to the other one. That's why we are giving delta minus and delta plus. That is, it is not completely cation or anion, but just have a partial charge. Now, the speciality of inductive effect that it can extend only up to 3 atoms or 4 atoms. That is, we can see here chlorine is a minus I group. So, it will be pulling electron towards itself. We can see in the first carbon, the pull is very high. That is indicated by 3 arrows. But as we go to the second carbon, the pull will become lesser. That is, only 2 is there. Greater the number of the delta, lesser will be the charge. That is, lesser positive charge will be there. When it reaches the third carbon, it is very less and the pull is indicated only by a single arrow. And by the fourth, there is no partial positive charge at all. So that is the basic thing that we have to learn in inductive effect. Now we have to learn the groups in plus I effect, plus I groups, minus I group, and the applications of inductive effect. So these are the minus I groups in the decreasing order and the plus I groups in the decreasing order. So the group with the maximum minus I effect will be N plus Me3, and with the least will be hydrogen. But hydrogen can give both plus I and minus I effect. So we can consider the alkene giving least minus I effect, and primary the alkyl group, that is CH3, giving the least plus I effect. So right, please take down this part. This is very important for solving problems. In the end, I am going to show the questions that already came in IIT JEE examination previously from this part. So I hope you have all written down this. Now we will be going into the applications of inductive effect. We are having 5 applications of inductive effect. The first one is bond length. Minus I effect increases the bond length. We can understand that from this example. Consider these two compounds, that is CH3Cl and CH3F. From the previous section, we found that fluorine is having more minus I effect than chlorine. Fluorine greater than chlorine in the order of minus I groups. So we can see that more minus I effect is having the I'm sorry, this is I made a mistake here. This is decreases, okay? It does not increase but decrease. So here F is having more inductive effect, minus I effect, and it is pulling electrons towards it, and as a result the bond length will be decreasing. Compared to F, chlorine is having less minus I effect, so the bond length is more in case of this. Now the second point is dipole moment. No matter which kind of I effect is there, it can be plus I effect or minus I effect. In both cases, when inductive effect increases, dipole moment also will be increasing. So these two are the first two applications. This is one of the most important application of inductive effect, and questions have always come from this part. Always in the sense, most of the question paper we can see questions from this part, that is the stability of carbocations and carbanions. Let us see. Here the carbocation stability follows this order, that is tertiary carbocation is more stable than secondary carbocation, it is more stable than primary cation, and the least stable is the methyl carbocation. We can understand the reason. A carbocation is already having a lot of positive charge. So any factor which can reduce this positive charge will increase the stability. I hope you are getting. That is, it is already having a lot of positive charge. So if some way it can reduce this positive charge, then that will be increasing the stability. What is happening in tertiary carbocation? There are 3 different methyl groups, and methyl group is plus I effect group or the plus I group. Plus I group will be pushing electrons towards the carbon. So when more electrons are going towards this carbon, the positive charge will get reduced, and as a result it will become more stable. Now in secondary, it is having only 2 CH3 groups. So the amount of electron push towards this carbon is lesser than that from this first compound, that is the tertiary carbocation. Similarly, in primary it is again reduced, and in methyl there is no methyl carbocation. We don't have any CH3 group which is pushing electron towards the carbon to reduce its positive charge. But in the case of carbanion, how the stability will be determined? In case of carbanion, it is already having a lot of negative charge. So if more electron is given, it will be more unstable. That is, already it is having lots of negative charge. There is no need of giving more electrons towards it. So as a result, the carbanion stability will be exact reverse of the carbocation stability. That is, the least stable will be the tertiary carbocation, because 3 different methyl group are again pushing electron towards this carbanion, which is already filled with lots of negative charge. Okay, you understand this part? Now the application, the fourth application comes from this part only, that is the stability of the reactivity of alkyl halides. The reactivity of alkyl halides will be actually following from this one only. We can do that next. Now this is the order of reactivity of alkyl halides. Let us see why. In case of alkyl halide, greater the plus I effect increases, reactivity also increases. So here plus I effect is most in this one, that is the tertiary alkyl halide, and therefore it is more reactive. Why it is more reactive? Actually, when the alkyl halide reacts, we will be having a carbocation will be formed, that is X minus, and a carbocation will be formed. And as we already discussed, tertiary carbocation will be more stable. So the reactivity of alkyl halide also will be in that form. Tertiary alkyl halide will be the most reactive among all the alkyl halide. So this is the fourth application, and now we will go to the final application, which is the most important of all. Now towards the final application. The final application is the strength of carboxylic acid. So this is the basic point, that is minus I group increases the strength of carboxylic acid, whereas plus I group decreases the strength of carboxylic acid. We can see by using an example. So the strength of fluoroacetic acid is greater than chloroacetic acid is greater than pure acetic acid. We can see why. What is an acid? An acid is something which will be giving H plus ions. So after giving H plus ion, the species formed that are called the conjugate base. If the conjugate base is very much stable, then the acid will be very strong. So if the conjugate base is stable, then acid will be stronger. Out of these three conjugate bases, we can see that we have already discussed that if it is already having a negative charge, this negative charge should be decreased in order to become stable. Fluorine is a minus I group, that is it will be pulling the electrons. So as a result, this negative charge will be decreased and this will become more stable. That is why fluoroacetic acid is the most strong acid. Then comes chloroacetic acid, because Cl is having minus I effect, but it is having lesser effect than chlorine. It is not strong as fluorine. That is why this comes in the second in the order of strength. And finally, acetic acid is only having hydrogen in it, that is HCH2CO minus, and it is the least minus I effect group, and therefore that is the least strong or the weakest. No, we do not use the term, we do not use the term least strong. It is the weakest among these three. The weakest acid among these three will be acetic acid. Strongest will be the fluoroacetic acid, because of the minus I effect. Hope you understand. Now we will do two questions that have already come from this part, and we can understand how much you have learned in this part. So these are two questions which came repeatedly in different years from the inductive effect part. So this first question is arrangement. We have to arrange these three, that is CH3 thrice C, CH3 twice CH, CH3 CH2 according to increasing order of inductive effect. So basically what we have to do, we have to remember the order of the plus I effect group, and which comes greater, that should be written as last, because the increasing order from small to big we have to write. So which is the smallest? This one will be the smallest, since it is the primary alkyl group. So CH3 CH2 less than CH3 twice CH2 CH less than CH3 thrice C. This will be the answer. Very simple, directly from the order we have found out. Next question. This question, the question did not repeat same way, but the same concept came in 2011 and 2013 or 15, I guess, came three times or something. So arrange the carbanions in decreasing stability. So first of all we have to check if any minus I effect group is there. So we are having minus I effect groups in 2. So which is the greater minus I effect group? Cl. So minus I effect group CaCl3 minus will be giving most stability to the carbanion. Then comes C6H5 CH2 minus. Then you see we are having two more. Out of those, which one is having less plus I effect? Here one is CH3 thrice and other is CH2 twice. Obviously CH3 twice will be having more stability compared to the other, because it will be having lesser plus I effect. So this will be the order, and we can write all these questions directly from the order that we have studied. I hope this part is very clear to you, and any doubt in this part can be asked in the comment section, and in the I will be doing more electronic effects in the coming videos, and we will be solving the combined questions as well that came in previous year IIT JEE examination. Thank you for watching. Please subscribe our channel and ask for any videos you want. Thank you.